Session 9. Contour map. In this session, we learn about its definition and the general rules of contour lines and how to process and present the results. Definition. Contour line of a function of two variables is a curve along which the function has a constant value. It is a cross-section of the three-dimensional graph of the function f xy and parallel to the xy plane. In cartography, a contour line, often just called contour, joins points of equal elevation above a given level, such as mean sea level. A contour map is a map that illustrated with contour lines. For example, a topographic map, which thus shows valleys and hills, and the steepness of slopes. The contour interval of a contour map is the difference in elevation between successive contour lines. More generally, a contour line for a function of two variables is a curve connecting points where the function has the same particular value. The gradient of the function is always perpendicular to the contour lines. When the lines are close together, the magnitude of the gradient is large. The variance is steep. A level set is the generation of a contour line for functions of any number of variables. And here's the sample of contour map. And then we have 10 general rules of contour lines. Number 1. The contour lines never cross each other. And number 2. The altitude differential of contour lines should be constant. Number 3. A region with higher altitude is always in the same side of a contour line. And 4. The contour line always forms closed plane. 5. The distance of contour line shows the sloping area. Closer means steeper. 6. The contour line in shape of closed circle, which has same center point and higher to the center, means a hill. 7. The contour line in shape of closed circle, which has same center point and more low to the center, means a hole or depression. 8. Irregular line indicate the uneven sloping. 9. The valley area is drawn by V-shaped contour, whereas the steep slope in U-shape. 10. V-shape of river flow direction west indicates the upper course of river. And processing and presenting research. There are some steps in processing the data to make the contour map. Generally, the steps is a form of mathematical calculations, where the results are come from approach. Here are the steps to make the contour line. Okay, in the picture we can see there are 2 points. The first point has height, or we can say the first point has elevation of 673.4 meter, and at the right point the elevation is 696.2 meter, and the contour interval will use 5 meter. So the contour line passed through the following elevation is 675, 680, 685, 690, and 695. And this time in the map we have 10 centimeter, which, for example, and the altitude differential we get it by 22.8 meter. So here's the distance of point measured from the first point. As you can see at the equation, we have that the first point is 0.7 centimeter, the second is 2.9, and 5.1, 7.3, and 9.5. And here is the first point, second point, third, fourth, and the fifth. We can make it as a point. And then another contour line passes through the same elevation as below. And here is the distance, just like before. And we draw it just like this. Okay, as you can see, here are the point. And here's the point before. Now, here's for example for big things. We have some points here, or we can say that if we have a little map here, and we should draw it by contour interval 5 meter. And here we find some points, and then here, 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 here. And then we draw a line that connect point to point that have same value. And here you can see that it draws the 440 elevation, and then 135, 130, 425, 420, 15, and 10. Now here is the contour map. As you can see that there is a little example. You can draw it into a large example. I think that's all for this session. Thank you.